Hello everyone, wishing you all a very good evening. Am I audible and visible to all of you?
Yes, sir.
Okay, all have come. Ayush, Kaushiki, Tanish, Vedansh. Is there anyone missing? Or everyone is there? Kaushiki, hi.
Hi.
Vedansh,
Yes, sir.
Tanish,
Yes, sir.
everyone is there? I think someone is missing. I don't know why.
सर मैं आयुष
आयुष तो है तू कोई और मिसिंग है क्या क्लास में? Let me see. I think someone is missing. I don't know why. Just let me see. So, tell me what we were doing in the last class. What we were doing in the last class? Tell me that.
Sir, displacement.
We were dealing with displacement, right? Okay. What did we do in displacement?
We defined it and then we said that displacement and distance can't be
They are different
can't
quantities,
be-
right? They are, one is vector, the other one is scalar and all that. Okay. Now, let me give you some more examples where we are trying to find out the distances and displacement. Do you have any idea about the Pythagoras theorem? All of you know Pythagoras theorem?
Yes, sir.
What is Pythagoras
Yeah.
theorem? Tell me.
Sir, hypotenuse square equal to base square plus perpendicular square.
Okay. Now, here is a question for all of you. A boy is going in a straight line from A to B. Then he goes from B to C. Okay. Looks like a straight line. This is point A, this is point B, this is point C, this is 3 meters, and this is 4 meters. Now, my first question is, number one, what is the distance traveled by this body, or this man, or gentleman, or car, or bus, or whatever? What is the distance traveled by this person?
सर 7
5 meters. Oh,
Kaushiki,
sorry.
distance traveled by this.
So
Is
7
7
meters.
meters. How did you get it? You just add 3 meter with 4 meter, yes or no?
Yes, sir.
Anyone has any doubts on this?
No, sir.
It exactly, it is pretty simple. Ayush, Kaushiki, Tanish, Vedansh. Okay, now let me talk about the displacement of this particle. Let me talk about the displacement of this particle. Now, whenever we talk about displacement, we must always think of two things. What are the two things that we must think of?
Initial point and ending point.
Initial point is A,
A.
final point is C. Remember, displacement is a vector quantity. So you must always think about magnitude and direction. Tanish, what is the magnitude of displacement?
Sir, A.
A. Okay. I think you are new in the class, right? Vedansh, how will you get the displacement here?
Sir, a straight line from A to C.
We'll have to draw a straight line from A to C. In fact, not a straight line, we have to draw a vector from A to C, right?
Yes, sir.
So AC vector is our displacement vector. Now this displacement vector has two things. One is the magnitude. What is the magnitude of the displacement vector AC? It will be the length of this straight line. Yes or no?
Yeah.
Kaushiki, what is the length of this straight line? AC?
5 meters.
5 meters. How did you get this 5 meters?
The square root of 4 square plus 3 square.
So AC square is AB square plus BC square. Yes or no? If I call this as the base, I call this as the perpendicular, this side becomes the hypotenuse. Yes or no?
Yes, sir.
Yes.
Hypotenuse square is perpendicular square plus base square. 3 squared plus 4 squared is hypotenuse squared. So basically 25 becomes my hypotenuse squared. So my hypotenuse becomes 5 meters. Yes or no?
Yes, sir.
Okay, so the
Yeah.
magnitude of displacement, if I just write it here, the magnitude of displacement would be 5 meters and the direction would be,
The vector AC.
yes, so you can just say from A to C. You can just say it from A to C. You can also say that displacement is simply AC vector. This is a better way of saying displacement. Sir, displacement is AC vector. It has two things. What are those two things? One is the magnitude, which is 5 meters, and one is the direction, which is from A to C. This is a better way of saying the same thing, but if you say it in this way, you'll probably understand it better. Am I clear with this point? Ayush, Kaushiki, Tanishq, Vedansh,
Yes, sir.
Yes.
do you have any doubts on this?
No.
No,
Tanishq,
sir.
Tanishq,
No, sir.
Pakka? Is this your first class, beta? Tanishq, is this your first class? Did I lose Tanishq? Tanishq, are you there? Is this your first class?
Yes, sir.
Okay. समझ में आ रहा है?
Yes, sir.
Okay. अगला सवाल. अगला सवाल है ये. Again, two straight lines. It goes from here to here 5 meters, A to B. From B to C, the distance traveled is 12 meters. The question is from A to C. From A to C, you have to tell me the two things. One is the distance traveled and the other is the displacement of the particle. Can you do this?
Sir, distance 17 meter.
Well done. Distance 17 meters. Well done. What about the displacement?
13 meters and
How?
in the direction A to C.
How did you get it, beta?
AB square plus BC square
So
equals
basically,
AC
you have to
square.
first. Why is my line not going? You have to first draw a straight line from A to C. Then you can call this as AC vector. Yes or no? So your displacement is basically your AC vector. Yes? We agree on this?
Yeah.
Ayush, Tanishq, Vedansh, we agree?
Yes, sir.
Yes, sir.
It has two things. One is magnitude. The other one is direction. You all know the direction is from A to C, straight line. What about the magnitude? To get the magnitude, you have to find the length of this line.
It's 13.
Yeah, so if I call this as the hypotenuse, this becomes your base, this becomes your perpendicular. So my hypotenuse square becomes perpendicular square plus base squared. And that will be 5 squared plus 12 squared. So this will be, I think, 169. Am I correct?
Yeah.
So my hypotenuse basically becomes 13 meters. So the displacement magnitude becomes 13 meters. Do we agree on this?
Yes, sir.
Yes, sir.
Anyone has any doubts on this?
No, sir.
Pakka?
No.
Okay. What next? See, as far as your school's exams are concerned, whatever I told you up till now is much more than enough. How much they have covered in your exam? I mean, they have covered this chapter completely, yes or no? They have covered this chapter, yes or no? है ना? What I'll do is I'll give you one more question based on this and see how do you fare. Now remember, these are the 4 directions that we know. Yes or no?
Yes, sir.
Yes,
North,
sir.
south,
Yes.
east, west. We know this. Now keep this in
Yes.
mind and answer the question. A person walks 3 meters n means
North.
and then 4 meters east. Find the distance and displacement. You can assume that the initial point is O, and the final point you can call it as A, B, whatever. Or you can say the initial point is A and the final point is C. So you can start with the initial point A and you can call the final point C. You have to tell me what is the distance traveled by this person and what is the displacement of this person.
The distance is 7 meters
Okay,
and the displacement is 5 meter in direction A to C or AC vector. I mean,
how to do it? Kaushiki, how to do it? Simple, no?
you sort of have to visualize it, but it's the
Visualize
same as
it.
the old
So
question.
let me say that I start from the point A. Now remember, let me draw this so that I remember what is my east, what is my north, what is my south. This is north, this is west, this is east, and this is south. So first of all, I have to go from A to some point B. I am going north, and how much distance I have traveled? 3 meters. Do we understand this, everyone?
Yes, sir.
Then from north, from this point B, I have taken a turn and I have moved towards east. I have moved 4 meters towards east. So this distance is 4 meters. I have moved 4 meters towards east. And this is my final point C. Yes or no?
Yes, sir.
What is my distance traveled? Now you can tell me the distance traveled. What is the distance traveled?
7 meters.
7 meters. What is the displacement? Now, up till now, you must understand that whenever you have 3 and a 4, the displacement is from A to C, AC vector. Yes or no?
Yes, sir.
And how much is that?
Five
Thi-
meters.
This is hypotenuse. Hypotenuse square is base square plus perpendicular square. 3 square plus 4 square ka root. So my answer will be the magnitude of displacement. Remember, the magnitude of displacement is 5 meters. And the direction of displacement is from
A to C.
A to C. Actually, this direction is given in terms of this angle. How to find this angle? I'll just leave it right now. So I will not tell you how to find this angle, but this is how this question is done in totality. Instead of saying the direction from A to C, we should always tell what? Some angle with the north or some angle with the south. This is how a question is done in higher standards, in your 11th standard. Instead of just saying from A to C, you will say that angle is this much. Got it?
Yes, sir.
Question number 4. Now, I will not draw the diagram. You'll have to draw the diagram and see if you can do this. A man walk from A to B, 2 meters north, then from B to C, 1 meter east, then from C to D, 2 meters north, then from D to E, 2 meters east. I hope you understand this. Again, you have to find the distance traveled. So I call the distance traveled as L, and delta R. Remember delta R? What is delta R? Vector?
Change.
In position vector. So it is known as displacement vector. Yes or no?
Yeah.
So L is the distance traveled and delta R vector is the displacement. Can you tell me the answer for this one?
So the distance is 7 meters,
Great.
and so is the displacement. So is the magnitude of the displacement.
Magnitude of displacement is also 7, Kaushiki? No, no,
Yeah.
no, no, no.
From the initial point to the ending point.
Think. Think. I'll give you 2 minutes.
Sir, 9.
What is 9?
Sir, displacement.
Oh, sorry. Is it 5?
What is 5?
The displacement.
Yes,
Magnitude of the
yes,
displacement.
that is 5. That is 5. That is correct. That is 5. How did you get it?
You add up whenever he moves north, and then whenever he moves east, and then you just make that right angle triangle.
Okay. Okay. Shall I solve it? Now, how to do this? Let me start from this point. Let me call the point as A. What I've done is, I've drawn the direction. This is east. This is north. I don't need west and south, so I'll forget about west and south. The first thing he does is moves from A to B here. How much is the distance? 2 meters north. We all agree on this? Yes or no?
Yes, sir.
Then he moves from B to C 1 meter east. So I just write 1 meter, B to C, 1 meter. Then he moves from C to D north, C to D, 2 meters north. So far, so good. Not a problem. Then what happens? It moves from D to E, and this is also 2 meters. We all agree on this?
Yes, sir.
So what is the displacement? It is straight away this vector AE, right? Now let us first find the distance traveled. What is the distance traveled? Two plus 1, 3. 2 plus 1, 3. 3 plus 2, 5.
8.
5 plus 2,
8-meter distance.
7 meters, right? 7, no?
Yes, sir. 7.
Yes, sir. Yes.
Okay. What about the displacement? Now, if you have to find the displacement, this is simply the vector AE. Yes or no? Now, this vector
Yeah.
AE has a magnitude. It also has a direction. The direction is from A to E. So we can just straight away write. What about the magnitude? You have to find the length of this line. Yes or no?
Yeah.
Now look at this. This is 1 meter and this is 2 meter. So this one becomes 3 meters. Yes or no? It becomes 3 meters.
Yes, sir.
Now look at this one. This is 2 meters. Oops, I've drawn it wrong. Let me just erase them because the colors are getting confusing. Even I confused. Okay, let me write it again. This is 2 meters. This is 1 meter. This is 2 meter and this is 2 meter. Correct? Now, looking at this green one, this is 2 meter and this is 1 meter. This becomes 3 meter. Correct?
Yes, sir.
Now, you have to find the length of this line. How much is the length of this line? Look at the blue one. This is 2 meters vertical and this is also 2 meters vertical. So how much this becomes? This becomes 4 meter vertical. Yes or no?
Yes.
Look at the blue one. A to B is 2 meters. A to B is 2 meters. And C to D is 2 meters. So 2 plus 2 becomes 4. Yes or no?
Yes, sir.
B to C is 1 meter. D to E is also 1 meter. So 1 plus 2 becomes 3 meters. So it is 3 meters in this direction and 4 meters in this direction. Yes or no?
Yes, sir.
3 square plus 4 square का under root करेंगे. So what will you get? You will get 5 meters and 5 meters is what? The magnitude of displacement. Am I clear?
Yes, sir.
Yes. Yes, sir.
Everyone understands this? Kaushiki, do you understand this?
Yeah.
Ayush,
Yes, sir.
Tanesh, Vedansh,
Yes, sir.
Yes, sir.
Vedansh, any one of you understand this? This is good. Can I give you one question that you will be able to solve? Or is it good enough that you understood this?
I understood.
Understood, everyone? So shall I move forward?
Yes, sir.
Okay. Now see, I have, did I send you some notes? Did I send you some notes on the app? Have you seen those notes? Did I send you some notes? Have you ever gone through what notes I have sent you?
Yeah.
Yeah. What those notes are about? Where are these?
So some of them have like notes on SI units, points, definitions about what we're learning. So when we did that motion topic,
Nah, so have you gone through those notes, beta?
a few of them.
Few of them. Okay, let me see where is your note. Which notes have I sent you? No, not this one. Which one have I sent you? Let me have a look. Okay, I got it. Sometimes I get confused. I got so much of things. Okay. Okay, we've got distance, displacement. Okay, now what I'll do is we'll do a couple of questions from this regarding distance and displacement, and then I will ask you to solve some problems on your own as homework. Would you be able to do this?
Yeah.
Okay.
Yes, sir.
Just a moment. Just give me a moment. I should be able to get you that. Takes time. My laptop is giving me a problem today. I don't know why. Just not working fine. Just not working fine. Okay. Just not working fine. Just not working fine. Something or the other thing is happening. Okay, doesn't matter. Now do you see this? You see this, right? Okay, here is the question that we are talking about. Question number 1. Do you see this? Question number 1. A person travels a distance of 5 meters towards east, then 4 meters towards north and 2 meters towards west. Calculate the total distance and calculate the displacement. Can you do that for me? Have you got the question, everyone?
Yeah, I got
Yes,
the
sir.
answer.
You got the answer as well?
Yeah.
Well done, Kaushiki. What are the answers that you got?
The total distance traveled is 11,
Yes,
and then the displacement is 5 meters.
great. What about the others? Well done, Kaushiki. Well done. Did you do it before this class?
No, it's kind of just logic because 5 east, 2 towards the west, and so then it's just
Okay, good. Well done. I'm impressed. Well done. Anyone else got this answer? Have you read the question, Kaushiki? 3 meters towards east, 4 meters towards north, then something, something. Let us try to solve. How many of you got this? Only Kaushiki got it? So let me draw the diagram. Kaushiki, would you help me out? Let us say he starts from A. Where does he move first? Remember, do not forget where are your north, south, east, and west. This is east. This is west. Just Kaushiki, continue.
he
North.
moves 5 to the east.
So should I move right?
First.
Should I move left?
Right.
Right. So all right. So I move right 5 meters. Every one of us agrees on this? Ayush, Vedansh, Tanish.
Yes, sir.
What
Yes.
next? What next?
4 meters north.
What do you mean by north? Up, down, right, left?
Up.
Up. Kaushiki says 4 meters up. So I move 4 meters up. What next?
And then 2 meters left.
2 meters left. 2 meters towards west in the question. So here it is left. We all agree on this, everyone?
Yes, sir.
Well done. Now the first question is find out the distance. What is the distance, everyone?
Sir, 11.
Sir, 11 meter.
5 plus 4 plus 2 and the distance yellow one is 11 meters. We all agree on this. Well done. Let us talk about distance now. How do I get the distance? I make tongue vector like this. My displacement is the vector AD. Yes,
AD.
the direction is from A to D. Forget about that. Let us find out the magnitude. How do I get the magnitude? I drop a line like this. What is the length of this line?
Sir, 4 meter.
Very
4 meters.
good. Well done. What is the length of this portion? It is not 5 meter, remember. If I
3
call this as
meters.
if I call this as E, remember this total line A to B or line segment is 5 meters. From here to here, it is given as 2 meters. So it becomes very simple that this becomes 3 meters. Yes or no, everyone?
Yes, sir.
Yes, sir. Then I look at 3 meters, sir, which is the length of this part. I look at 4 meters, sir, which is the length of this part. So what will be the length of this part? Again, right angle triangle coming into the picture. What is the length of this part? It is definitely 5 meters. Yes or no, everyone?
Yes, sir.
Yes, sir.
So my answer is 5 meters. Anyone having any doubt, please raise your hands. Or you can speak as well. No need to raise hands, you can speak. Do we understand this?
Yes, sir.
Yes,
Any
sir.
doubts, anyone?
No, sir.
How many of you could do this question? Tell me. How many of you could do this question? Tell me. No one?
I could.
You did? Kaushik, did. What about others? Vedansh, Surya, Vedansh,
Yes, sir. Did.
you did? Ayush, Tanesh,
Yes. Yes, sir.
okay. Here comes the next question. This is example number 2, taken from your notes. I hope you have your notes with you. You'll keep them open in your mobile phone so that you can have a look. A body is moving in a straight line. Good choice. Its distance from origin are shown in the time. With time in the figure A, B, C, and D and E respectively. So it is moving A, B, C, and D. C, D, and E are different points on its journey. The distances are shown. What they've asked is the displacement of the body in the first 2 seconds, distance traveled in 7 seconds, and displacement in 7 seconds. So first we have to find displacement in 2 seconds, then we have to find distance traveled in 7 seconds, and then you have to find displacement in 7 seconds. Do we understand this?
Yes, sir.
Yes.
Okay, how do I share multiple windows? Now the diagram is also given to you. So I will now show you the diagram here. The diagram is given to you as well. And this is the diagram coming to you right away. This is 2 seconds. This is 7 seconds. Let us see Who can tell me what is the distance traveled from 0 to 2 seconds? Look at the diagram. What is the displacement of the particle in 2 seconds? Who will give me the answer for this one? For first one. What is the displacement of the particle in 2 seconds? So look at 2 seconds where the particle is, how much it has moved, what is the displacement? Anyone has an answer?
Um, I'm not
Kaushik is trying.
sure, but 60 meters.
60 meters is what Kaushiki feels. What about the others? There are also others in the class. What do you think?
Yes, sir.
Yes, sir. Who
Yes,
is
sir.
this?
60 meters.
Yes, sir. 60 meters. So is everyone saying 60 meters? 60 मीटर को लॉक किया जाए? किया जाए?
Yes, sir.
तो लॉक किया जाए. 60 meters is the correct answer. Congratulations, everyone. You have won a jackpot. What is the second question? The second question is, what is the second question? The second question is, what is the displacement? What is the distance traveled in 7 seconds? What is the distance traveled in 7 seconds? Do you have the answer for this one? Do you have the answer for this one? What is the distance traveled in 7 seconds? If you can give this answer, I will be really happy. Anyone who gives this answer. Anyone who gives this answer. I will be pretty happy.
160 meters.
160 meters is what Kaushiki thinks. Kaushiki, why? What makes you think that it has traveled 160 meters?
Because first it goes up 60 meters, then it's in the same thing. It doesn't move for the next 2 seconds. Then 20 meters up again, then 20 meters down, and then 60 meters down.
Remember, distance traveled is never negative, it is always positive. So when it goes from A to B, it moves a distance of 60 meters. Yes or no? Everyone?
Yes, sir.
Yes, sir.
So B to C is 60 meters. We all know this. A to B is 60 meters. B to C does not travel, it is at rest. So the distance is still 60 meters. Yes or no?
Yes.
Yes,
From
sir.
C to this point, top, it again moves 20 meters. So 60 plus 20 becomes how much?
80 meters.
80 meters. Then again it moves. It might have moved downwards, doesn't matter. It might have turned
Yeah,
back,
I
doesn't
still
matter.
added. I
So
still
this,
added.
you still add it. So it is still
Yeah,
plus 20. So it becomes 100 meters. Yes or no?
Yes, sir.
And then this is again 60. So 100 plus 60. The total distance traveled is 160 meters. Do we all agree on this?
Yes,
sir.
sir.
Kaushiki, we agree on this?
I said that.
Okay, so Kaushiki says that, so that means Kaushiki agrees with this. Shall we move on to the last part of this question? The last part of this question is, what is the displacement of the particle in 7 seconds? Listen to the question carefully. What is the displacement of the particle in 7 seconds? Kaushiki, Ayush, Tanishk, Vedansh. Tanishk, are you getting the topic or not?
It's 0.
Displacement is 0. Kaushiki says 0. What about others? Ayush, Tanishk, Vedansh, what do you think? What is the displacement of the particle? आयुष, तनिष्क, वेदांश, क्या लगता है क्या हो रहा है? Kaushiki, what makes you think that displacement is 0?
Because no matter how much it travels, the initial and final point is the same.
Yes, it started from 0 origin, and when it finishes its journey, it is still here at the origin. Time has changed, but its position has not changed. It has come back to its original position. Yes or no?
Yes, sir.
So it might have moved 60 meters ahead, but 80 meters ahead, but it came back 80 meters. So if I treat one as positive, the other one becomes negative. Yes or no?
Yes, sir.
So Tanish, Vedansh, the displacement becomes 0. Yes or no?
Yes.
Yes, sir.
Tanish, समझ में आ रहा है?
Yes.
पक्का?
Yes.
Okay, so this was the question on distance and displacement. Now we'll go on and discuss some points here. So again, these are questions taken from your sheet. Too many questions. They cover each and every aspect of this. Listen to this question. Question number 29. Displacement of a body can be 0 even when the distance traveled is not 0. Explain when this can happen. Displacement of body is 0, but the distance traveled is not 0. When this can happen? Who will tell me?
When it can move in any shape, but the initial and this final point has to meet.
We don't say meet,
Be the
Kaushiki,
same.
are the
Sorry.
same. So as we saw in the question that we just attempted, it was moving. The distance traveled was 160 meters, but it came back to the same point from where it started. Its initial and the same. Its
The
initial and the
position
final.
are same.
Its initial and final position were same. Yes, beta. And in that case, distance traveled will be not 0, but displacement will be 0 because initial and final points are same. Are we in agreement with this statement, all of us?
Yes, sir.
Tanish,
sir.
Vedansh, Ayush, Kaushiki,
Yes, sir.
everyone,
Yes.
together.
Yes.
Comes the next question. What is the SI unit of displacement?
Meters.
Well done. Who will answer the next one? Displacement is a dash quantity, distance is a dash quantity.
Vector quantity.
अरे
Displacement is
दोनों बोल लें,
vector
दोनों बोल लें.
Vector and
The
then scalar.
displacement is a vector quantity.
Displacement is a vector quantity and
Distance is scalar quantity.
distance is scalar quantity. We have to give both the answers. Well done. We are doing well. So if you remember all these small things, you should be doing well. Again, another question comes up, and here it comes. Tarak on your screen now. Question number 65. I will not read the question. Give me the answer.
False.
Distance moved and displacement are always equal. Is it true or is it false?
False.
Sir, false.
It can
False.
be equal, right?
Yes, sir.
In what case is it equal? Tell me that case in which it is equal.
When the initial and final are the same.
No, Kaushiki, not correct. When is the
Equal.
distance traveled equal to the displacement of the particle? Remember, I told you distance can never be equal to displacement. It is equal to the magnitude of displacement. When does that happen? When the particle is always moving in a
Straight line with no
straight
change in direction.
change in direction. It should always move in one straight line without ever changing its direction, not going here, not coming back. If it changes its direction, displacement ka magnitude will always be greater, no, will always be less than or equal to distance traveled. Do we agree on this?
Yes, sir.
Everyone agrees on this. Can I have raise hand from everyone that we agree on this? You know how to raise hands in this? Ayush has raised hand. What about Kaushiki? Kaushiki, Vedansh, Tanishk, are you there in the class? Kaushiki?
Yes.
Okay. Tanish, समझ में आ रहा है?
I'm
ताली बजा दी
trying to find the raise hand button.
Okay. Okay. Coming on to the true and false question number 66.
मुझे नहीं जानना है वैसे भी.
Distance moved may be greater or equal to displacement. Yes or no?
Sir, false.
Distance moved may be greater than or equal to displacement. True or false?
True.
Sir, true.
In what case is it equal? Equal to magnitude of displacement. I just told you right now, just now.
When they're moving in a straight line in the same direction with no change.
Well done, Kaushiki. If a particle moves in a straight line continuously, never changing its direction, then distance traveled and magnitude of displacement becomes equal. So we have done almost all the questions that were possible in this part of your chapter, distance and displacement. We'll wind up today's class here. We've understood distance and displacement. In the next class, we will be dealing with speed and velocity. And we'll be doing your questions on speed and velocity. Remember, next class is on Monday. So we'll try to pace up your course. I think we are lagging behind, but we'll again try to catch up. Where are you, Tanish? Course में क्या कहाँ चल रहा है? Ayush, Vedansh? School में क्या चल रहा है?
Sir, force and laws of motion.
Shabash. Kaushiki? Kaushiki is sharing two things, right?
We're doing energy and how to convert energy.
Energy. Great. Tanishk? Tanish's laws. Vedansh?
Sir, force and laws of motion.
Force and laws of motion. So this part is done. Don't worry. We'll catch up soon. I'll end up today's class here. If you have any problem, you can ask me now.